Kidding. Okay, so here we go. Let's do this problem. So we had a student say that they personally would go about it by simplifying the bottom. You cannot go wrong as long as you don't break any math rules. So let's do it. Why not? Let's focus on the bottom. So anybody feel like it might be a good idea if you're really showing your work so you don't mess up? You don't have to do it this way, but if you're a person that needs to see every step, then wouldn't you probably reorder it? Yes or no? Okay, let's put the number first. 12 is first. Then we have an x to the 3/4.
Oh, we can't see it.
Okay, good point. Sorry. Okay, x to the 3/4. I'm going to just kind of cross out so I don't miss anything. X to the -1, crossing out. Then we have a y to the 3/2 and a y to the -2. Now, if we continue with the bottom, let's continue with the bottom. We know that right here, the mathematical rule is we want to, when we multiply, we add our exponents. Yes, everyone. Yeah, we're combining, and so we have to now use rules because we have fractional exponents. So now let's write the bottom again. We still have 12. Now we have to be able to go like this. X to the 3/4 plus -1. True or false? Okay, let's hurry and just show our work. So right here, when you multiply, you do what? When you multiply, you do what to your exponents? So then we have 3/2 plus -2. Now, yes, at this point, if you don't know how to add fractions, we're in trouble. So let's review it. To add 3/4 plus -1, we put divide by 1. We then get a common denominator. We're timesing by 4 to the bottom. We're timesing by 4 to the top. And now we know how to add fractions. You add the numerator. Yes or no? Okay, so I have to once again rewrite this so I don't get confused. I draw my line. I put my 12. I put my x. What is this going to be when we add it together? 3/4 minus 4/4 is how many fourths?
-1/4.
Let's just write it and leave it for now. Okay. Then right here we do the same thing. Divide by 1. We get a common denominator. Isn't the denominator 2? Times by 2. Times by 2. Yes or no?
Yes.
Okay. So then from here, let's add the numerator together. What are we going to get? Y to the 3/2 minus 4/2. So is it -1/2?
Yeah.
Okay. From there, then we have now done what one student would do, simplify the bottom. That's not a problem. All right. Then if you choose to do it that way, you're probably a student that's also going to simplify the top. Yes?
Yes.
So reorder it. We have 3 times 2. Should I write x to the 0? What is x to the 0?
1.
So is it necessary to write times 1? That seems silly. So I'm just going to not. Then I'm going to put my x's next. X to the -2. Looks like there's no other x's. Then my y's. Then I'm going to simplify that. We know what 3 times 2 is.
6.
It's 6. Okay, then right here. Oh, just x to the -2 for now. I'm leaving it for now because I'm focusing in sections so I don't get confused. When you multiply, you... So we need to get a common denominator. I put divide by 1. I times by 2 to the bottom. I times by 2 to the top. I'm adding those together. Yes?
Yes.
So right here, -2/2 plus 1/2 is -1/2. Okay, so then we have y to the -1/2. I'm going to put the most simplified top on the most simplified bottom. So I'm going to then shimmy this right here. 6x to the -2, y to the -1/2. Now you cannot go wrong. You cannot get the wrong answer as long as your math doesn't go, like as long as you don't mess up on math. So what would you do next if it were you? There's many ways to continue.
Divide 6 and 12.
Okay, divide 6 and 12, and we got to do this correctly. Yes, we're not going to be the sad soul that doesn't divide fractions correctly. This becomes a 1, and this becomes a 2. So now we're going to draw a fraction line. We have a 1 on top, I'm not going to write it, and a 2 on bottom. Okay, now what? Anyone have an idea what they would do?
I would cross out 2 y's.
Oh, dang. Oh, dang, I didn't even notice that. You're saying that anything divided by itself is 1? Smart idea. Let's just get her gone. Sweet. I didn't even notice that because my eyeballs had not gone there yet. Yes.
Now you can do the qualitative property or whatever.
Yeah, the quotient property. Okay. And if we do that, what do? We put x on top, and what do?
Minus the bottom.
Yep. So you do -2 minus -1/4. Do you guys see how he's choosing not to fix negatives? That's okay, right? Is that mathematically correct, what he's saying? Then let's roll with it. Why not? We know that minusing a negative is just adding. So now you'd say, okay, I just need to get a common denominator. I write in my denominator of 1. I'm timesing by 4, timesing by 4. So then that's negative 7 fourths. So watch, what I'm going to do, I show my work so I don't make an error. X to the negative 7 fourths, and then 2's on bottom. Now, if I circle this as my final answer, if this was worth 10 points, you'd probably get a 9 out of 10. Still pretty good, though. You did all the hard stuff.
You need to switch the exponent to the bottom.
Okay, so you're right. Negative exponents in a final answer are considered not very pretty. So we know to fix a negative exponent, we flip the base over a fraction. So that means we're going to take this and flip it right here. And now it's a positive exponent. Now don't be the sad soul that says the final answer is 2x to the 7 fourths. What was left on top? 1. So we put a 1. On bottom was 2x to the 7 fourths. And we know we're as simplified as it gets. There's only one number and one x. Does everybody see?
Yes.
If there was 2 x's, you didn't go wrong. You need to keep going. We can put 2 x's together. True, everybody? Yes. If there's still 2 y's in your final answer, you're not going to go, oh, great, I didn't do it right. No, you just need to keep going. Awesome. So you guys, hopefully you're seeing that that's not that intimidating as long as you focus in sections and you just don't make small mistakes. What are your questions on that? You've got to ask. How to ask. All right, let's move on. All right, we're learning a new property today, which is pretty straightforward. So let's keep going. Once again, focusing so that we can actually have some homework time today. Okay, let's explore this right here. This is 1.2. Let's explore something to a power. So let's say that we're dealing with something that already has an exponent and then we raise it to a power. What does something to the third power mean?
Cube.
It means, it means it's still
Cubed, yes.
squared and then cubed.
Okay, so you're saying that this is something times itself 3 times. So let's show it visually. That's what I mean by visually. Here we go. We have x squared. I'm going to write it up here. X squared times x squared times x squared. True?
Yeah.
So then from there, we know when you multiply the same base, what do you do with your exponents? You add them because that's where we're at this point. So what are we going to get? X to the 6. Now, also visually, if you were really going for the visual effect here, you would have written it out like this. Does everybody see how it's x to the 6?
Yeah.
Makes sense. Now, that's really annoying to have to write it out like that. So instead, let's come up with a trick so we can just go much quicker. Yes?
You can just multiply the 2 exponents.
Yep, if you have a power and it's raised to an additional power, you multiply the exponents. Now, if you're wondering why, we just showed you why visually. It's just learning the trick's going to make your life quicker. So it's not better. I mean, yeah, kind of better because it's quicker. So we just see that if you have a power and you raise it to an additional power, you multiply the powers. So this would be x to the 2 times 3, which is x to the 6. Notice we got the same answer no matter how we did it, but it's just different ways of getting there. This is the quickest way. So this is kind of what we call so we have the product property, which means you're multiplying the same base. The quotient property means you're dividing the same base. This is kind of what we just call like the power rule. Power rule. So if you have a power raised to an additional power, you multiply the powers. Okay. So like, for example, easy purposes here. What is y to the 2nd to the 5th? Y to the 10th. Yes, everybody? Because we multiply, because it's a power, then raised to an additional power, we multiply the powers. Good. All right. Now, look, a lot of people will have these 2 rules, and they'll get them confused. Look at the difference. You guys, we're in honors. We should be able to really focus and then pay attention to the details. Right here, do you guys see how there's the same base? And they each have their own power. There are 2 bases here. They have their own power. This is when you multiply the same base, you add your exponents. So this would be x to the 5th. Right here, there's only one base. It's raised power to a power. These are different problems. Do you guys see the difference? One has 2 bases, one has the 1 base. Power to a power, we multiply the powers. All right, so let's look at something else. Just watch this one. Okay, right here, when you see this, you got to pay attention to parentheses. We know parentheses mean focus on me first. So if we were to focus inside the parentheses, does anything in here combine? No, you move on. After parentheses is exponents. Is there an exponent on the outside? So what you do is you take care of that. Now, this means we need to raise every piece to the 3rd power. Now, be very careful. That does not mean 2 times 3. You guys, is 2 to the 3rd power equal to 2 times 3?
No.
No, it's 2 to the 3rd power. So I'm showing my work. 2 to the 3rd, and then it's x to the Raise a power to a power. You multiply, yeah? So
Yes.
6. Raise a power to a power, and you
Y to the negative.
multiply, -6. So then from here, you'd say, that's my answer. It's just not simplified. What is 2 to the 3rd calculate to be?
8.
We put an 8 then. Is x to the 6 good to go?
Yes.
All right. How about y to the -6?
Flip it.
You're right. Negative exponents aren't considered a great final answer. We're going to take that, flip it down under a fraction, and now it's positive. There's only one number, one x, one y, so that's as simplified as it gets. No negative exponents. So just don't overcomplicate it. It's the same rule no matter what. So if you have right here division, you just have to make sure to raise each of these to the 1/2 power. Yes?
Yeah.
So this would be x to the 1/2 power, y to the, do you guys know that when you multiply fractions, you multiply straight across? So look, this is like divided by 1. If we multiply straight across, 2 times 1 is 2. 1 times 2 is 2, which is, yes, so we have x to the 1/2, y to the 1. Okay, good. And then right here, we have 3 divided by 1, so we do 3 times 1 is
3.
3 on bottom. 1 times 2 is 2. Boom, there it is. Okay. So once again, just be careful. We get the picture. Let's just start with some examples. So if you want to, I'm going to give you a second to actually write it down while I put in my roll. Because I know we do, yes, you're going to be okay. We do go fast, so sometimes it's hard to write down an example. I get that, but you're going to get used to it. And you're going to end up liking it. Because really, most of your practice comes from you watch, you also participate, and then you go to the homework and you figure out what you don't know so you can get help. So you can then show me that you know what you're doing for a test. All right. Okay, I think I got everybody marked absent. That's absent. Okay, you cannot go wrong. Now, you do have to go in the correct order of operations, though. So it's PEMDAS, right? Parentheses, exponents, multiplication, division, addition, subtraction. This is how we simplify something. PEMDAS, yes?
Yeah.
This is like the order they recommend simplifying so you don't go wrong. All right, let's focus inside our parentheses. Is there anything that can be simplified? No, you move on. Are there any exponents that need to be simplified? Yes, right there. Yes?
Yeah.
All right, let's do it. We have a power to a power, a power to a power. Now, I rewrite all of it, even if it can seem like a pain in the butt. Well, does anyone want to get rid of this right here, right now?
Yes.
All right, I'm fine with that. We have a y to the -1/2. Now, on bottom, I have a y to the b.
Second.
Yes, it's second. You guys look, 2/3 times 3. Do you guys see how he's getting second so quickly?
Yes.
That's multiplying a fraction. Okay, so then we're getting 2 right there. Then what are we getting for x? Power to a power, we multiply the powers. That's -3. Now, you cannot go wrong. So how do you, if it were you, what would you do? And you might do something different than your neighbor.
I'd cross out the 1.
Oh, you're saying y squared and y squared could divide out?
Yeah.
Sure. Okay, good. What would you do next if it were you?
Then just switch them.
You're saying a negative exponent's not simplified? That is true. So we're flipping our bases over a fraction to make a positive exponent. So on top one, I have x cubed. On bottom, I'll have y to the 1/2 and done. You just focus in sections. You got this. All right, let's look at another one. You guys have got to ask questions. So if you're like, wait, I don't get how you get x to the 3rd, then you need to ask that. Yes.
Well, the exponent is 0, so you just get rid of that.
Yeah, so we learned last time that x to the 0 power calculates to be 1. So we could write 1, but that's a time sign. Anything times 1 is just itself. So it's easier just to kind of be like, that's going to become a 1, which isn't, it's not that it goes away completely. It's a 1, but we don't really need to write it there.
Yeah.
Good question. All right, I'm glad you asked that. Okay, moving on. Do you guys want me to give you a second to write it down? Or just go like a maniac? Which one?
Second, write it down.
Okay, I'll give you a second. Go, go, go. I like to simplify in the order of PEMDAS personally. So that's me. I focus on parentheses. Then I do exponents. Then I do multiplication, division, addition, and subtraction last.
So parentheses, just do everything first. Get everything simplified first, probably.
Okay, let's get everything in the parentheses simplified. Now, you might do it different than your neighbor. It does not matter how you do it versus your neighbor as long as neither of you make a mathematical error. So, what is your preference? Anyone?
I just take out the X's right
Oh, those x's don't divide out. We got to be careful. Are those the exact things divided out?
You'd add them together because one's a negative, so you minus it from the top and that'd be added. You get
What you actually are doing, because you're doing it in your head and you're going to confuse people, but I like it. I can see what you're saying. Okay, he's saying he doesn't want negative exponents. Okay, everybody? Do you guys agree? That might be nice. Okay, so he's taking this up here. And now it's positive. Yes?
Yeah.
I think you said X.
Okay, and then you're right. So then now I can say when you multiply the same base, you add your exponents. So we're getting x squared. Does everybody understand? Now, also, if you choose to go that route, you probably fix all negative exponents. So let's take this base downstairs. There's already a y to the 3/4 downstairs. We now have a y to the 2/3 downstairs. When you multiply, you add. So we got to go like this. We're adding 3/4 plus 2/3. I'm going to times by 3/3. I'm going to times by 4/4. And then personally, for my brain, I'm going to rewrite this. This one's 9/12 plus 8/12,
17.
which is 17/12. So now I know that y is just one y. That was the point, putting it to be one y. We added our exponents and we got 17/12. We now simplified in our parentheses. Now I have to put the -3 back in because I was focusing there. Yes.
Could you just flip it first and then add the 3?
Yeah, there's so many orders you can go. Yep. Flip what first, though?
Flip the x2 to the bottom and the y 17/2 to the top.
And make it positive? Yes, you could.
I think I got the answer.
All right,
You
so
have x to the 6.
there's many ways to go from here. Do you guys understand that?
Yes.
Okay, personally, this is just me. This is only me. There's people doing it quicker than me, and that's fine. I'm going to do, okay, I know that all of this has to be raised to this power. So I know right now I do power to a power and I multiply. So right now I have this. Yes, everyone? Okay, then right here, this is just me. Right here I'm multiplying. So I have times -3/1. We multiply straight across. If you don't know what 17 times 3 is, no one's judging. I'm going to take my calculator. -51. So I have y to the -51 divided by 12. Then you're like, my answer is getting better. Yeah? Isn't it? It's getting closer and closer to simplified. Is that an acceptable final answer? No, you're right. Negative exponents we need to write as positive. So we take y to the positive 51/12. I almost said negative. We know when we flip it, it becomes positive. And then we have x to the 6 on bottom. And aren't we good to go? We only have one y, one x. Now, yes, you're all thinking very advancedly. So you were asking, could I have instead just flipped these and made it +3 from the beginning? Yes. But if that confuses you, that's okay. Like, that's why we all do it our own way. We then check each other's final answer. You know, like, I'll check with you because I don't do it the same as you, but let's see if our final answer is the same. If not, one of us messed up. All right. Do you guys want to try one by yourselves? Okay, let's do this one by ourselves. Okay, here we go. You guys just be careful. Now that you're in Sec 2 honors, you are expected to just be a little, like, not make so many little errors. So just be diligent, pay attention to your negatives. It, like, just takes focus. Hyper focus on the problem. So do not allow your brain to drift off and think about Sally Joe. Because you're right, then you're going to mess up.
I cannot think about Sally Joe.
Sally Joe's always in my mind.
Okay, so I'm going to stop this video and then start recording again so it's not as long. So you have to help me. Remember to video record, okay?